All right, so let's get started. Let's do a one sample t interval for a mean. So in this question, we have a random sample of 10 cars of a new model, and they were tested for their gas mileage. And it gives us the results, 27.2 miles per gallon. So what is that? It's the mean from our sample. So what symbol am I going to write?
Mu.
Not mu, right? Mu would be for a population. This is going to be y bar. All right, because this is a t interval, we're actually not going to have anything about mu. Our statement, our conclusion at the end about this interval will be about mu. But in terms of the work, it'll be all y bar. Okay? It gives us a standard deviation of 1.8 miles per gallon. So that's S equals 1.8 miles per gallon. Now our sample size is how many cars? 10 cars. So what's our degrees of freedom?
9.
It is 9. Very good. All right, for this week, it's always the sample size minus 1. All right, sample size minus 1. So that's a fairly small sample. All right, so this t-distribution model that we're going to use will look different than the normal model with such a small sample. All right, so it wants us to run a 95% confidence interval, all right, to estimate the gas mileage achieved by this model. All right, a new car. Okay, so here we go. The formula is y bar plus or minus t star, and I'm going to go ahead and put n minus 1. Jarvis is 9, right? Degrees of freedom is 9. All right, times the standard error of y bar. Do you guys remember that formula from yesterday? It's okay.
Y bar.
Standard deviation.
You're doing for the t value. Very good. And I put S for the sample standard deviation. All right, and again, these will all be given to you, not the 9. Obviously, that'll say the n minus 1 for your formula sheet. All right, you'll get this on Friday. Tomorrow. Okay, so y bar is 27.2 plus or minus. Now, here's where it's a first change. With proportions, when you see a 95% confidence interval or level, because we are using the normal model with proportions, you would write what? 1.96. We're not going to write 1.96. I'm going to go find it. Okay, you ready to find it? So you'll get these links. Actually, no, I'm not going to use MathCracker. I'm going to use this t-distribution. I showed this to you yesterday. Okay, so how many degrees of freedom? 9. Now watch this. This is what I really like about this. All right, I actually want to find, it says X here. I want to actually find this T critical value. So I'm going to plug in something here. All right, so watch how I'm going to do that. This is a 95% confidence interval, correct? So if I do 95% here, how much is in each tail? Very good, right? Because you have 5% to split. So right here is 0.025, same with right here. Now this is the same work we've been doing for weeks now. What am I going to type in? What am I going to type in to that applet to give me the T critical value? Very good, Jarvis. What's another one you could type in that would give you the same thing? You can't type in 0.05. Very good. How'd you get that, Leslie? She said 0.975, which is correct. Very good, right? If I plug in this one, that's what I'm going to use. I'm going to get the number is negative. If you type in all the area to the left of this one, 0.975, you get the positive version. It doesn't matter. It's your choice. My brain just wants to do that. Okay? So let's type it in right there. 0.025. Well, the X is where it's going to give me the T value. You ready for this? So it gives me the T value. All right.
So the red one is the 95%?
No, so what goes in here is how much area you want to the right or to the left. I should have changed this. Let me change it for you. You know what? Let's do this. Let me zoom in so you can actually see it. Okay, now you guys can actually see it. Okay, so what I normally would type in is this. All right. Nope, don't want that. All right, what number did I say I want to type in? Come on. All right, fine, you win. Go away. Thank you. I don't want any of that. I don't want any of that. Okay, let's try again. Okay. I don't know how to delete. Let's just tab. What about there? Switch. Switch. Okay, one way, good. Okay. So what I would type in here. Now it's not going to work. Son of a. There we go. You okay? There we go. Tab. Okay. Finally got it. 0.025. And now if I click the blue one, so that's what we use for, remember Desmos, the inverse norm? We use that link for the last test. You could find that t critical value. So this really, if I was redoing this, right, see how it says x is that? I would say, I would just change this to be t. Like this is the t value. Okay? So we're saying the area to the left, which I showed you, was 0.025. That t value is 2.262. That's what I'm writing down. Do you guys see how that's a big difference from 1.96? Why is that such a big difference? Why are those so far apart? Very good, Catherine, because our sample size is so small, right? What if instead of a sample size of 10, I had a sample size of 100? I'm going to do this again, but my degrees of freedom would be 99. What do you think is going to happen to this number? It's going to get closer to 1.96, right? We're trying to get closer and closer to the normal model, right? The bigger our sample size is, the closer this t model is to normal. So watch what happens when I change it to 99. Well, I got to do, let's not mess this up again, Douglas. I'm going to lose followers. Okay. Whew. All right. Okay, I don't know why you hate me so much. Ready? You guys want to see how close it is? 1.98. Now we're really close. Right? That's what I was trying to show you yesterday, is that the bigger your sample size is, so the bigger your degrees of freedom, the closer it is to normal. Remember what I told you guys at the very end of class, right? My teacher had me do what? When I was in high school. If this sample size, degrees of freedom, was over 25, then I just used what? I used the normal model with z's, right? Which, when I went to college, I realized that's not okay. Can't do that, right?
So for the 95% confidence thing, it always has to be 2.0.
So your F wants to know what is it going to be, right? Because you know it's not going to be 1.96. Here's the problem, your F. If I change the sample size, so the degrees of freedom change, then even if I use the same confidence level, this will change. So what I'm saying from now on, for means, you've got to use this link.
Yeah,
Always.
But you would always put, like if it's 95, you would always
Correct.
put,
Okay, you can memorize that. This will always be, if you change it. I mean, remember I had it greater than, it gave me the same thing. So you can always use that 0.025 for 95%, and then for 90% would be 0.05. Yes, you can memorize that, and then this will change what your t value is. Okay, times. What is our standard deviation from the sample? 1.8 over the square root of our sample size, which is 10. Every year when I do this, I get a lot of students that start putting in their brain, just kind of morphs these together, because we were focused so much on degrees of freedom to get our T star. All right, so just make sure that this is N, not degrees of freedom. And just every year I get students that would type in 9 there. Okay, so just be aware of which one you're using. Is it sample size or is it degrees of freedom? Okay, so if we use our yellow calculators, we can multiply 2.262 times our standard error. All right, I mean, just give me a second. 1 point. Oh, well, Douglas, if you type in 2.622, that's going to be a problem. I am not good, so I'm about to be good. Still not good, Wences. Still not good. Okay, now I'm good. Okay, 1.2. Well, honestly, what I would do is I would put 1 point. I mean, the problem goes to the tens place, so I would go one past it. So 1.29. But I'm not that worried about rounding, guys. Okay, so if we add and subtract our margin of error from 27.2, you get 25.91 miles per gallon. And 28.49 miles per gallon. All right, so here's the statement you're going to write. I am 95% confident that the average miles per gallon for all of these new model cars is between 25.91 miles per gallon and 28.49 miles per gallon. Okay. Yes, Charlize. I took the estimate, right? This is our statistic, our sample mean, and I added and subtracted our margin of error. So if you take this number minus the margin of error, you'll get 25.91. Did I do it wrong? Okay. Question, David? No.
So you're not using percent?
I'm not, right? This week is all about, I mean, I guess Tuesday wasn't, but like this new unit is all about means. It's all about averages. They have units, right? I don't have any percentages. I mean, I do, right? But you know what I mean. We're not with proportions anymore. Do you guys want to see the buttons for Math Cracker? Shall we do the things with Math Cracker so you can see how it works there?
Yeah.
Okay. There are fish out of water? Oh my gosh. Oh, freshman and senior high? Got it. Okay. What is our sample mean? Not yet. Soon. 27.2. Our sample standard deviation. 1.8. Our sample size. 10. And then our, what do we got here? Confidence level. 95. So I'm going to put 0.95. Excellent. Calculate. Wednesday.
Did you get the ad?
I did get the email. I clearly have not used it yet, but I will. If it's a virus and something happens, I'm going to come after you. Okay? Yeah, like have you seen Taken? I have a particular set of skills, and I will just email our IT person. Okay. Did it work yet? Oh. I know, right? No, I'm sure it's just the ads. All right, we got it. Okay. Now, what I really like about this, okay, and what some of you are going to really like about this, is that it gives you the T critical value. Remember how I used this applet to calculate the T critical value? It's not this, I changed it, but like the 2.262, remember that number? That is given to you in the solution. So that's really nice. You don't have to, or if you're struggling with that, it's in the solution, okay? So they're taking this to find the standard error. You can see they just did a little bit different math, right? They went ahead and put that in the numerator, but it's all there. All that same work is there. And you can see we had rounded to 1.28, so we obviously rounded early, and so our numbers are a little different. All right? Absolutely. I will have all the links for you. Now, here's the thing I noticed. I don't see, I mean, it has a statement, but like it's not in context. It's not really helpful. So make sure you know what's right for the statement. Okay? Any questions on an interval? Really on the quiz? Yes. Go for it. We do have a quiz tomorrow. It will be on the quiz, but not in like running it. It will be on finding which one I would use for the interval. We'll practice on an exit ticket problem in your packet.
Is it gonna look like what we just did?
No, and what we're going to have tomorrow on the quiz is going to be a test. You're going to have to run a test.
Like this.
Like yesterday?
Yeah, no, remember I said you're not going to do the assumptions and conditions tomorrow?
Oh, bet.
You don't need a bet, I'm telling you.
So it's like
What? No, so tomorrow we're not going to do an interval. It'll be like, since you guys want to know, like this, where I set them up and you got to choose which one. You know what I'm saying? That makes sense? Okay. Okay, can I go over this little nuance thing with finding the sample size? Let's do that. So you don't have this. So you're going to look for it. You're not going to find it. So is there a blank backside? So let's go. I'm almost done. Flip your packet all the way to the backside where it's blank. Blank. No, it's not going to be on the quiz. It could be on the test, though. Not until after spring break, but like our next test. I'm sorry, what was the answer, Emily? What's that? No, you have a question. The last one?
it wasn't on here.
Which one? No, that one we had. This one? I thought I put that in the packet. Is that not in the packet?
Yeah.
That was in the packet. All right. So find a spot for this one. Really, I just want to look at number 2. Okay? Now, in number 2, what they're saying is, I guess I'll give you the whole problem. So they have an insurance company, and the insurance company is keeping track of the average life expectancy for their policyholders. So people that purchase life insurance policies with this company. All right, and so they are always keeping track of how old people are, all right, when they're dying, because that will change how much they're going to charge you. Right? It's all about that risk. Okay? So they're looking at this sample of, let's see, how many is that? Is it 20? 1, 2, 3, 4, 5, 6, 7, 8. 20 people and their ages. But number 2 is what I want to focus on. It says, for an accurate cost determination, they want to estimate the life expectancy to within 1 year. So within 1 year. So remember, our formula is margin of error equals T star with our degrees of freedom. You don't have this solo if you were listening. You're flipping over to the very back and you're writing this down. Times the sample standard deviation over the square root of n. Now, here's the problem when you do this. Okay? We know our margin of error, they're saying within 1 year. Okay, so our margin of error is 1 within 1 year. Okay? For a 95% confidence level, and with proportions, we use 1.96. But as I showed you, to find this with means, when you do it, you need to know the degrees of freedom. Well, how do we get the degrees of freedom? Where does that come from? The sample size. But guys, what are we solving for? The sample size. So we can't do that. We have 2 unknowns, so we can't figure out what it is. So what we do is we use 1.96 first. I know, it's weird. So we're going to use 1.96 first, okay? Times, and then our sample standard deviation. I think I deleted it, so let me calculate real quick. So if you want to follow along in the calculator, all I'm doing is going to data, and I'm typing in these 20 numbers. You don't have to do it. I will be done in 30 seconds. Are you counting? It's a lot of pressure. Right? Skip. He's not speaking. Where did he go? I'm still here. I'm still here. Don't leave. Has it been 30 seconds? All right. Sometimes. All right. No. All right. They're not like real comments. Okay, 4.4. They are 4.5.
That's the standard?
Yes, the standard deviation is 4.5. Okay, so I went to my calculator and found the sample standard deviation. It was 4.5 years. So I plugged that in for S. So now you're going to do your algebra like we did before. with proportions. You're going to divide 1 divided by 1.96. Then you're going to, so this is going to be fun. Let's do this different algebra. 0.510204082. Okay, everyone still with me? All I did was I took 1 and divided it by the 1.96, so move that over. Okay? So now, all right, the way my brain does it is I see the square root of n in the denominator, and I want to move that to out of the denominator. And then I'm going to move this number over there with division. So in the calculator, I'm going to divide 4.5 divided by the number I just wrote, the 0.51 number. And I get 8.81 and a bunch of decimals, bunch of numbers after decimal. And then I'm going to square it, right? Because see how it says the square root of n? I don't want the square root of n. I want n. So if I square it, I get 77.8 people, or records. So how many should I use? Very good. So the answer is 78 records. All right, but here's the problem, guys. Is that was using Z-star. All right, so now watch this, and you don't have to write this if you don't want to. So if I say my sample size is 78, what's my degrees of freedom?
77.
Very good. So my degrees of freedom is 77. So I'm going to go back to this little applet and type in 77. There we go. Plus. And then I want to delete this and type in, well, what's the confidence level? So as what your rest was talking about, 0.025. Yes, because it's 95 in the middle, so there's 2.5% on each tail. And then let's see what it is. It's 1.99125. So you might be thinking, oh, that's not much different. I mean, it isn't, right? 99125. But technically, if you want this to be right, if you want it to be accurate, you have to do this twice. So I'm just going to literally repeat the process. So I'm going to skip a bunch of steps. Okay? So I'm going to do 1 divided by 1.99125. Then I'm going to take 4.5 divided by that, and then square it. And I get 80.3. So how many records should I actually look at? 81 records. So really what most students see when I do this is that you just have to do it twice. Okay, the first time you estimate it with a Z-star, the old way, with a normal model. You know that that's wrong, so you get a wrong answer, but you use this to give you degrees of freedom to find the correct T-star, and then you can find...
That's 199 divided by 2.5?
No, you mean, wait, what?
That's 1.99 divided by?
No, that's a 1.
Is that 1.99125?
That's what it is. Yeah, I got it from here, so 1.99125, you see something? Because you always round up. Remember, you always round up. So I got 80.3 when I use T-star. So I need to use 81. Yes, you always want to round up to the next whole number. So if you were doing this for real and you only used 78 records, we could not guarantee a margin of error of only 1 year. Okay, so that's why we have to do it twice. 81 records will guarantee us only a margin of error of 1 year. Yeah. Like the algebra?
Yeah.
Okay, well, I can show you on the calculator how I did it.